All right, so simplify each of the following expressions. So we're looking at these logs. So once again, what you want to remember here, so if I had something like log base b of x equals y, what you're basically doing is, it's b to what power will give me that value that's being evaluated of the logarithm right there. So really, you're just looking for what exponent, like in this example number 19, what's the exponent of 4 to give you 64? And so the answer is 3. There's your answer. That's it. So because 4 to the third power is 64, so you need to know this conversion right here. Okay. This next one, so 5, how does this turn into 1/5? So the exponent would be -2. That would cause it to reciprocate and then square it. So you get 1 over 25. Next one's a little tricky, so I'm going to write it down. So 16 to what power? We'll just call it y. You can call it whatever you want, equals 4. How does that 16 shrink down to a 4? It's not going to be negative. You're not going to reciprocate it, because if you reciprocate it, your result will actually be less than 1. So if you were to flip it, you're going to get a very small number. So it's actually going to be 1/2. And the reason why is, and you need to know this, if you have some value raised to the 1/2, that's equivalent to square rooting that same value. So you want to make sure you know that. Okay. So that 1/2 will cause you to square root 16, which is 4. So we want to make sure we know that. All right, so moving on. Um, this one's pretty easy. 17 to what power gives you 17 is just 1. Raising to the 1 power gives you the same result. 3 to what power gives you 3 to the power of 8? That's kind of silly. It's just 8. Okay. Right here, you need to know this, that natural, clean that up. Natural log is just base e. So actually, y'all should know that. So anyways, it's base e. So e to what power gives you e to the power of 5? Just 5. Pretty simple right there. Okay, so this next one's kind of a combination of the ones we kind of saw up above. So it reciprocates, but then also square roots. So the reciprocal part makes it negative, and then the square root part makes it 1/2. So -1/2 would be the exponent required to turn 3 into 1 over the square root of 3. Here, let's see. So remember, it's base e. So e to what power gets me 1 over e to the power of 2. So it'd have to reciprocate and be a power of 2, so it's -2. So if you were to put a -2 there, it would reciprocate, and you have 1 over e to the power of 2. Okay, if there is no base listed, it's understood it's 10. So trying to figure out 10 to what power gives me 1 over 1,000. So I'm writing them down, the ones that are a little bit more challenging. If you can do it in your head, that's fine too, though. So it's going to flip and then turn into 1,000. So that would be 10 times 10 times 10 to get the 1,000. But in order to get it to be the reciprocal, it's got to be negative. So it's -3. So if you were to do 10 to the -3 power, that would get you that 1 over 1,000. I think I might have said 10,000. Sorry, 1 over 1,000. Okay, so this next part is going to be using the properties of logarithms to expand them as much as possible. Okay, simplify if possible. I don't think any of these will be able to simplify. So right here, you see you've got a product. So we'll go ahead and break that apart into log base 9 of c to the power of 5. And then let's see, that's going to be addition. All right, so I cleaned that up for a second. I paused it for a moment. And then let's see, log base 9 of the cube root of a. All right, so most of us probably already see that, we want to move that power right here. And what you need to realize is that radical is actually an exponent also. So we're going to want to move that too. So I'll do that in 2 steps. So the first one, I'll go ahead and move. So I'm going to move the 5. So I'm going to have 5. Clean this up a little bit. All right, so I'm going to have 5 times log base 9 of c, and then plus log base 9, and then that cube root is the same thing as raising to the 1/3 power. So that's what I did there. And so the last move I need to do is I do need to go ahead and move that 1/3 right here. So my final result is going to be 5 times log base 9 of C plus 1/3 log base 9 of A. And so that is that part right there. Okay, so this next part, let's see, we'll deal with the quotient first. So I do have a quotient. I'm going to break this apart into the natural log of x to the power of 4 square root of y minus, because of the quotient right there, natural log of z to the power of 5. So I got a couple things I want to take care of here. So we'll go ahead and break this apart, and then we can kind of deal with the exponents. I'll go ahead and convert that to a power of 1/2 also. So I'm going to do 2 steps at once. So we're going to start by doing natural log of x to the power of 4 plus natural log. I'm going to go ahead and convert that to a power of 1/2. It's going to save me an extra step. Then I do have the minus natural log of z to the power of 5. All right, so then our last move that we'll want to do here is go ahead and move those exponents. So go ahead and move it here, here, and here. All right, so let's see what we get here. We get 4 natural log of x plus 1/2 natural log of y minus 5 natural log of z.